So I'm kind of interested. Firstly, a tagline for the company Salix, digital assets marketplace for science. I was fascinated to know quite what that meant. And then some of the industries and technologies all sort of interest me. So yeah, what does Salix do, and what do you do at Salix?
Well, we're coming from the scientific field, so we are chemists.
Yeah.
I'm the CTO and my colleague is the CEO. We're both doctors. And one of the problems in chemical industry, especially in Germany, is it's not digitalized.
Okay.
So what we decided to do is look at this angle and try to offer solution for the digitalization of the chemical industry, basically chemical industry 4.0. Mm-hmm. That's what we call it. So we are developing the platform, which includes holographic user interface.
Okay.
Let's call it classical chemistry solutions like predicting new molecules, designing new molecules in a digital world. And since we're also aiming at the Industry 4.0, we're also thinking about IoT solutions within the industry. And that's where the digital asset marketplace comes in, because we are making this on a blockchain.
Okay, yeah.
What makes us different from the other people that do blockchain, we don't use any cryptocurrency.
Well, have you come across, there in Berlin, a company called Ascribe?
Yes.
Yeah, so there's a few people doing asset.
Yes.
But,
yeah. Most of the people, when they say blockchain, there is some underlying altcoin or something like that.
Maybe. I think that's changing quite rapidly, but yeah.
So basically that's what we do.
Okay. So is it using that to sort of like patent equivalent or something else?
Yeah, basically the blockchain layer ensures who has the data, whom the data belongs to, where it did come from, where it goes. So it's a proof of rights, basically.
Okay. And what's the IoT component? Also, you've got noted on the technology.
Well, we are, myself, I'm an organic chemist by education, which switched to computational chemistry years ago. So we always envision this part of the organic chemistry, especially at the industrial scale, where you would have some robots that would do all the chemical experiments without the humans. So that's what we call this IoT, which is basically robotics and automation.
Okay.
So this is the part.
Okay. So you're building software and hardware, or?
We are building the software. We are planning to prototype with some sort of robots, like based on Intel chips or Raspberry Pis. But of course, I'm not sure that we are going to do it ourselves in the future.
No, I mean hardware.
So we are more interested in software and then proof of concept, and then let's see where it goes.
And so what stage are you at the moment?
So the blockchain marketplace is ready. We don't have the very nice GUI interface, but I'm working on it. But the backend solution is finished. So basically the platform consists of the 4 units, let's call it this way. So we have digital design of the molecules that is working for predicting some properties like odor, because we are focusing on this particular angle at the moment. So we have designed our software that explains why molecules have particular odors and things like that.
What was the motivation to start the idea in the first place?
The platform itself?
Yeah.
Well, we are both young co-founders and we wanted to do things differently, let's call it this way. Myself, I was a bit frustrated with the academia.
Okay, yeah, fair enough.
So I wanted to do things differently. My colleague was also not in a mood to do the 9-to-5 job. And his pet project was this aroma chemical, so odor. And I'm quite fascinated with the blockchain.
Yeah.
We are both chemists who work in the same office, and we decided to do something together.
Okay, and how long have you been doing it for? Oh, Q2 2017. Okay, yeah.
Well, I mean, we are sitting in the office for the last 3 years. We started doing it last year.
Okay. And do you have any funding, or you just?
So these outdoor studies have been founded by Volkswagen Stiftung via experiment program.
Okay. So I guess, I mean, at least you're looking for about 300 to 500,000 here. I don't know how accurate that is, but I mean that seems for high tech science. That seems relatively small amount.
The relative small, yes. Because first of all, I focus on the chemical application field, so really bring the company to the level where we can predict a lot of other properties. Because we started with outdoor, which is not the most easiest one, to be honest.
No. Yeah.
Because there are other properties like photovoltaics or conductivity, probably, that would be much easier. I would think that there is like really linear regression.
Okay.
So we would like to expand the company in that direction, have some PhDs that would do work for us, and in that sense, that's why we're asking not that many, millions, because we can still use the academia for that.
Okay. Because I've met a few biotech, I don't know, science tech, I'm not even sure what we want to call it, companies. Have you met any of the others the past couple of days that you've been impressed by, or?
I've just came back from the pitching competition that is happening now, and there are two companies that did catch my attention. So one of them is trying to identify bacteria in the food, and the other one was quite interesting. They were developing in silico cancerous drugs, so that's quite closer, sort of, to us.
Okay. And do you think is it a good industry to be involved in Germany, or?
Yes and no, because
as I learned today, Yes.
I think no for the time being, because it's still kind of, we need much more powerful to move this very heavy locomotive, because the industry has been relying on the manufacturing and the principles that have been laid down for centuries. Because German chemistry has been, a background for many chemical industries. Yes, because Germany is going about digital solutions. So it's about time.
It's actually I didn't even realize that the whole Industry 4.0 was a German and partially Japanese, I think, but mostly German term quite recently. Do you think that's a good strategy, or?
Well, the Industry 4.0 has been a term, and it's been nearly everywhere on the press. As we learn ourselves hard way, it's a very fancy commercial word, but no one, or actually very many, not many people doing anything about it. So it's a very good, buzzword.
Yeah, for sure.
So if you want to attract attention to your article, you can use, we're doing something for Industry 4.0, and then you just talk about whatever. That's how the situation is at the moment.
Well, so what do you think it is?
I think it's about a bit of mentality and people not talking to each other, industry not talking to each other. I think it's also a social aspect. We have an excellent experience with the Nordic societies. I have been to Finland many times. We have good contacts there. And Nordic countries have been digitalized for years.
Oh, yeah.
Of course, being exposed to that culture and coming back to Germany, you are going like, oh my god, why?
Okay, so who are you? Who's ubirch? Ubirch, depending on how you want to pronounce it.
No. I don't think the association to Uber played any role.
No. I was going for whether it should be pronounced in the English way or the German way.
Yeah, it's in the English way, I guess.
Birch, yeah.
Because it's really... I won't tell you the story. It's actually quite boring, but it's related to a birch tree.
Okay. So who are you, and what is the company? What do you do?
Okay, I'm responsible for business development in the company. I'm actually not one of the founders. I joined the company lately because one of the founders, or the founder, was the biggest chair in the company, was my former boss at my former job, and I like him, I like the topic, and it's quite exciting at the company right now. And what the company does is we in marketing speech, and then I will explain what it really means. In marketing speech, we're building unbroken and unbreakable chain of trust between pickup of data and recording or storing the data in the cloud, you could say. And the reason we do this, actually, this has to do with a little story which happened to this founder some years ago. He's a guy with many interests. He got interested in all of this maker stuff and hardware. Finally, he's a psychologist by education, but founded a software company later on, and suddenly he discovered his interest in hardware. And one of the things he did was to make his own home into a smart home. And after a while, suddenly one Saturday morning, he heard some sounds downstairs from the family. They couldn't open the windows, lights were going on and off. They couldn't leave the house, the door was locked. They thought at first he was making a practical joke, but he was asleep. A hacker had hacked into his smart home. Not a very mean or nasty hacker. He just wanted to have a little fun. But after that, Stefan researched a little bit about harder security on the IoT, and what he found actually was not much. So security and IoT was and still is a kind of oxymoron. It's not a marriage made in heaven, and of course many people these days think about it, and you often hear from the major suppliers, not an issue, we are covered. You find industrial strengths, industrial standard security on our solutions, but to be honest, industrial standard security means we did not think about it much. We did not invest a lot of creativity or energy into it, and really that's the case. You cannot bolt on security after you already have finished the architecture of your IoT cloud. So, and that's where we found more or less the current vision of ubirch. So we set out to make the IoT more secure for personal and for professional reasons, and we're doing it by applying established cryptographic principles to data transfer and data storage. And what we make differently from industrial standard is industrial standard focuses on, you could say, transport level security. Transport level security is a standard term, TLS, but in addition it means that what you mostly do is you secure transfer of data from A to B, encrypted, decrypted, like HTTPS on the web. But this does not secure what is happening with the data once it has arrived in the cloud, for example. And that's much more attractive as a attack vector for any third party. It doesn't make much sense to attack these thousands or tens of thousands of connections with sensors and the cloud. It's much more interesting to attack the cloud systems or the cloud storage. And transport level security does not protect you from that. And in addition, there are some systems who do, some solutions which do similar stuff than we. I will get to that in a moment. But cryptographic principles always involve some kind of key. And they usually store this key centrally or do a backup or provision it centrally, and there you have a attack vector again. You just have to hack this kind of storage and then you can break into the system completely. So what we basically do is implement a public key infrastructure on the IoT, devices which implement our protocols. We built 2 of these devices ourselves, so 2 boards which you can integrate into other things. These devices generate a private key on the device, public key too, of course. The private key never leaves the device. It's in protected memory on the device. There is no backup, there is no transmission. And then every data packet being exchanged between this device and the cloud is signed. Yeah, it's packaged and signed. And this data then is transferred to our cloud. Finally, it goes into a blockchain, for example. And if we implement this right, how we do it, you can make certain that every data point you have recorded finally in the end comes from a certain device with a certain ID, which is anchored in the cloud too. Yeah. And of course, you can still manipulate the data, but as soon as you start manipulating the data, you will detect it immediately because it doesn't match the public key anymore. And this is what we implemented in a smooth and easy to integrate way. And we see a lot of applications for it, of course, otherwise we wouldn't have done it. For all business models where you really have to trust the data, or you more or less need to store it in a way that you can prove to others that this is exactly and this is everything you recorded from your devices. So the first vertical where this need is quite apparent right now is the insurance industry, actually. For sure. Yeah, especially what we found out, we weren't aware of that, especially in the reinsurance industry, the part where really the products are manufactured and then sold by what we call insurance companies. They have a lot of interest in that, especially right now, of course, for the big contracts where industrial where factories manufacturing devices, large scale, very expensive ones, are insured, where you really want to make sure that the owner of these devices has operated them in the agreed upon way. Stuff like that. So this is one of the verticals we are attacking right now, where we are finding a lot of interest. But all in all, where we see a very interesting area of application is the whole smart contract stuff. Because right now smart contracts you can only apply to purely digital business models. And I think...
Well, maybe. I mean, there's a lot of interest in supply chain and things like that, which is tracking physical stuff. But
Exactly. And as soon as physical stuff is involved, you really want to have an oracle in their terms, which can be trusted as much as some public website these days. Because many of these smart contracts are based on information you gather from public websites where you say, I can trust it because it will become apparent very soon if someone hacks it and so on. But just imagine your business model is depending on getting these data from little sensors, for example, in the supply chain, where certainly no one will go to the sensor and make sure that it's actually being measured there. But you have to trust the data, which is coming in the millions.
So there would be like a point, there's a point when the sensor is installed and it's checked and someone signs it to say, yes, this is accurate. And then if that changes, then it gives someone an opportunity to say, if something's not right, maybe the data from here can't be trusted anymore and we should investigate it.
For example, what we have integrated into our platform too is standard machine learning based fraud detection too. But in essence, of course, we cannot guarantee that the pure sensor will work right. If you have a light sensor and someone puts a hat over it, it's something we cannot influence. But as starting at the point of the sensor, we can really guarantee the data which is gathered there is exactly what is reaching the cloud. And even more, if you record a kind of protocol, if you more or less make a ledger, that blockchain principle, we can put in a trusted timestamp for each data getting in, and we can make sure that no data is deleted, no data is added, nor it is modified without being detected.
So to add this layer of trust, as you've described, do you have to use your end-to-end system, or can you use the sort of trust element on top of another IoT platform?
Yes, of course. It's we are not that large or ambitious that we say we are building the all-encompassing platform for the future IoT. Our solutions are being meant in a way to be integrated into existing platforms. We are trying to get corporations running with the established players in the market, the Siemenses, the General Electrics, Bosch, even with companies like SAP who are offering stuff in that area. So we would like to become a component in their offerings right now.
This is actually very interesting because Germany has kind of coined this Industry 4.0 term.
But it's just a term.
It's just a term, but it often involves more data-intensive industry, shall we say. And then also Germany and Austria and Switzerland, the German-speaking countries, are very almost always correlated with security and trust. So it's kind of it's sort of almost in exactly the right place.
You could say this, but I don't think this describes the situation precisely, because where we are really sensitive in this area, I think, is more data with regard to privacy. I think
maybe, although I think, especially when I speak to Americans and things, you often when you hear of a company from Germany or Switzerland, especially Austria, a little bit, people always think, I can trust them. It's often whether you think it's true or not. That's what people think.
To a certain degree, I think it's true. For example, in the last company, I was working together with my current boss. Our business model actually was based on trust too. So we really had to trust the records which our clients gave us at the end of the month to build them, because we could detect some anomalies, but in the end we could not really measure how intensively they were using our solutions. And without going too much into prejudices, this business model worked fine in some countries,
for sure.
And it didn't work so well in other countries where business culture was different, where it was okay to cheat your supplier, to be honest. So this is certain, but what we are doing right now, and that's where part of the relationship with the blockchain comes into play. Everybody's doing blockchain these days, of course. And the blockchain is one part of our solution because it is a distributed, decentralized way to establish trust. And that's why it fits perfectly into this kind of approach.
Yeah, exactly. To be honest with you, I'd say last year everybody was using blockchain, including a whole lot of people who had no valid use case. Whereas this year, most of the people I've met actually have a valid use case for it, which is good. I think a lot of people just went, ooh, and then why are you using it? Oh, because no, that you could just use a database. But now a lot of the companies I've met this year have been much more.
And it's true, and the market, even from the technological side, is becoming more mature. For example, what we are doing in the end is something which generates a lot of data. High frequency, high volume data, at least potentially. Right now, most of our test cases are not that. Are not big data, but in the end, of course, it will get into the area of big data. This is not something you can stuff into a real public blockchain right now, because they are all high cost, low frequency, little payload applications, and that's, for example, why we build it. And this is quite established right now too. We have a sidechain, we have a private blockchain which is working high frequency, high volume. We anchor the data from time to time in a public blockchain. Actually, we're using mostly Bitcoin, which is rather expensive, but it works fine because it's very high trust. And this solution together is a highly trustable and efficient system to store and to secure big data.
Yeah, for sure. So At the moment, are you just in testing stage, or do you actually have some live clients as well? Or
In German, we would say "jein," yes and no. Yeah.
in English, we just say
We have
same,
projects.
really.
Yeah,
But
we
I've
have.
never heard this. I remember this for 50
Yeah, you
years.
remember "jein"? It doesn't work in English, I think.
I know you. Well, it doesn't work as tidily.
Yeah.
Yeah.
You would say yes and no. That's not as much fun as "jein."
The most direct equivalent might be kinda.
So we have projects with real customers,
Yeah.
even with paying customers right now. But it's, to be honest, it's what we call lighthouse projects, where we want to establish our technology and the principles we work with high reputation
Yeah, sure.
customers, more or less, marketing.
Yeah.
You could say, and of course, proving ground for our systems. So these are projects which are not yet business critical
Yeah.
for our clients. This is the biggest difference,
Yeah. No,
I would say. Yeah. But these are real world solutions. Two of them, in the insurance industry. Another one, actually in the industry 4.0 environment, which I cannot talk about right yet. And even with a consumer product, which is quite funny. Of course, it's a friendly company. One of our founders is a shareholder at the other company too. It's a project called Trackle. Quite funny.
Tracker.
Trackle.
Oh, Trackle.
Trackle.
Yeah.
Trackle. And it's a tampon-shaped device which a woman puts into the vagina when she goes to bed, measuring her body temperature
Okay.
very, very precisely.
Yeah. I think my wife might have written about. She does purely IoT coverage,
Yeah.
but she's not here.
Yeah,
I think she might have written about it and
it's a Cologne company.
not thought a lot of it.
Yeah,
but anyway.
they had a not Kickstarter. I don't know,
Yeah.
what's the other platform which is more popular in Germany?
Indiegogo? No, in
One of
Germany.
these platforms.
Yeah.
They were quite successful right now, and they assume that over time, when the machine learning is finally done, and for a greater number of test users, they will be nearly as good, really, as a pill. Yeah.
Sure.
Right now, if you're
Yeah.
just doing measurement, it's
Yeah, no. Connected
it's-
tablets. I've actually
Yeah.
heard she's mentioned this a lot. Yeah.
yeah. So this is
Yeah.
an interesting product too, where you want to make sure that the data stays private, that it is definitely attached to this device, that there can be no confusion, and stuff like that. So it's
Yeah.
an interesting
Yeah.
application, but we this is not our business model. We don't want to get into consumer products.
It's actually, I mean, it's a shame I didn't think of this earlier, but you have a few minutes left.
Yeah,
It's interesting because often IoT data has been considered kind of low value, like high traffic, low value. Like if you miss a few bits here and there, whatever. But I guess you're starting to add that layer of like actually more important IoT data.
yeah.
Or is it
This,
still
this is one side
Yeah.
of it. Another option, which is interesting with our approach, for example, in the public space, in the open data scene, with our kind of solution, you can actually transfer the data in the open by just publishing the public key to everyone. Everyone is able to read the transferred data and still cannot change it, cannot tamper the records. Yeah, so it's not always about privacy. We can be open and still secure.
Yeah, no, for sure,
So this is an interesting approach, which we are discussing with some German cities right now.
Yeah.
So that the system is still delivers trustworthy data, but in an open way, which others can analyze, where you can build machine learning models
But
on.
you can trust its source. Yeah, that makes sense. So what are you at Pioneers for? What are you hoping to get out of Pioneers?
Contacts to people with money. Yeah, we're just raising. We had a first seed round last year.
Yeah, I saw...
We're raising right now again, and we had some interesting talks with VCs which we already knew, where we were just updating, and new ones which we contacted. And because right now I think our basic technology works, it has proven that it works, and we have to polish it. especially we would like to become more of a self-service platform.
Yeah.
Right now it's still very much project-oriented and doesn't scale too well. And of course, we would like to scale on the sales side too. Going into this business to market in the end will be people business. So we really have to ramp up sales, and of course we need capital to do that.
Cool. Okay.
Let me just start by showing you a couple of images so you can get an idea of like where we're going with Fable. Then I can give you a quick demo on how it works. It's actually not that complicated.
No, well, it shouldn't be really, I suppose. Yeah.
Let's see. So I guess that you're already aware that there's like this need to teach kids like 21st century skills, right?
Yeah. Yeah.
So there's also like statistics that like 47% of all jobs will be
Yep.
So 40% of all jobs will be automated by 2034. It's still debatable whether it's like 47% of each of the jobs that are in the market or if it's like whatever. But the fact is that we need to allow people to be creative, innovative, to help them pivot. So if there's a market change and they have to change careers on the path, then they have to be able to do that, right? There's going to be an increase in the demand for teachers. So we need to build tools that can empower them like to teach better. So what we did was that we built Fable. So we're a group of researchers. We helped collaborated with Lego to design the next generation of Lego bricks.
Yeah. Well, you're Danish, aren't you?
Yeah, we're a Danish company.
Yeah.
And, but we are by no means like sponsored by Lego or collaborating now. So the idea is like to build robots in seconds. So can we build a system that allows people to build robots in seconds? And our approach to it is Fables. So with Fable, you have like different types of modules that you can like snap, change, reconfigure. So you can build like snake robots like in a second, right? So you can imagine that if you build a
I'm making a little video. So
okay, sorry. So if you rearrange them in different ways, like for example with this guy here, you have a four-way branch, then you can just like take the legs out and start to build a walking robot. Let's build one.
I'll hold on here.
Yes, I don't want to drop it. So there's another one, and you can start to see like where this is going, right? Like this, and then like this. So now you have like a walking robot, and it only took a couple of seconds to build.
Yeah.
So then you can go directly to the app and start to program it. You can also download code directly to it, so you don't have to start from scratch. And you can reconfigure things and fix them, right? Because with other systems, like with Lego Mindstones, it takes like 4 hours to build something.
Yeah.
And there's a reason why they come with an instruction manual, right? Because it's gonna be pretty difficult to build something that's like better than the hero. So another thing that we're focused on is like to keep robots cheap and dumb. So by this, I mean that all of the computation is done remotely. So right now we use the PC, you can use your tablet, and eventually you will use the cloud. So that will bring the cost down on each of the modules, because each of the modules, they just focus on like our limbs, right? Like move here, move back, move front, and all of the high-end things like face recognition, text-to-speech, and all these things that are handled at the cloud.
Okay. Yep.
Another thing is that we want to build robots, have a tool that allows people to build real robots to solve real problems. And with Fable, we're getting closer to it. So we also design it so you can snap in cheap, small modules for the consumer version, you could say. And you can also snap like high-end modules for the industry. So we made a scalable connector that you can build this connector like in a larger size for the high-end motors, and then snap it together, and it's compatible.
Okay.
We also focused a lot on like growing together with the user, right?
Yeah.
So as I said, it's easy to assemble. We have a library of modules, so you can build your own creatures. You can build industrial robot arms, snake robots, walking robots. This is more or less like the app, like mock-up.
Scratch style.
Yeah, Scratch style. We also collaborated with like Mitch Resnick in the Media Lab.
Okay.
At some point, and we learned a lot from like block programming and so on. And then we decided to integrate it with Google's Blockly.
Okay.
So right now we put into production like these two modules, and these are like sort of like the library of things you can build.
They look very different from the other learning robots, that's for sure. But yeah, probably still videoing.
Sure.
But probably more accurate to what robots will actually look like. They don't tend to look like cute blocks in the industrial world, do they? So they look more like this.
More like this, right?
Yeah.
This is like sort of like more, and we're moving more into like a social thing, right? We tested the robot, the system, with more than 500 kids in Denmark, so close to 600 now. And one of the examples of like how teachers can use our system is that in this school in Denmark, they grabbed like a classroom, and they said, okay, we're going to make an innovation week. So they took the students to a retirement home, and they learned about the problems that the elderly had. And it was like things like, I dropped the remote control and I cannot pick it up, I cannot feed myself, and so on. And so what these kids did afterwards was they brainstormed solutions for them. They had 2 days to do so. So they used like our system, 3D printers, and also like a workshop and so on. And then Nikolai, he did a feeding robot for a woman that had Parkinson's, and then he pitched the idea to her, and he felt so empowered by her reaction that he then took his idea to a national competition, and he ended up in the finals. And then there were 2 other team members or groups that did the same, and one actually won the competition. So I was like a very exciting result, and we want to make that the mean and not the exception, right? So now we're working on an ecosystem of solutions on how can we make this happen. So we want to make educational materials that teachers can just download and teach with. We want to have adaptive learning. So imagine that you have like a classroom with 50 kids, and each of them has a robot, but the robot can tell if the kid is learning something or not, and he can help them. So the teacher, he only has to do like the high-level things. He doesn't have to go to each individual student and figure out if they're actually getting the information. We'll have different coding interfaces, like as we already talked about. It's like Blockly, Python, and then it could be Java or C Sharp. So it's language independent. We'll have educational apps to entertain kids, and we'll also have assessment tools. So we'll mine data from the different robots and feed it back to the teacher, so he gets a digested like a version of things, and he can focus his time on the kids that actually need his time. And then we'll work on sharing platforms to promote things that usually the educational system doesn't grade well, like if you work well in teams, if you help other people, if you share your knowledge, if you teach, you know. Okay. So just like to encourage kids like to do other stuff. Now we're working on an interactive app. It's I left my phone charging, but it's you get a pair of eyes.
Oh, it's actually it's on a phone as well. So if you put the phone in the
on a phone holder. Okay. So then you make a social robot as well. So then you can you tap into your phone because we have a Bluetooth communication as well. So then you can program the eye movements, so you can make it happy, sad, frustrated, and so on. And those will be simplified in blocks where you can say like, if you see mom, then smile, or then be happy, wave. So this will be launched in August this year, and we're working on more modules, raising fundings, and so on.
I mean, so. I mean, it looks very different from some of the others I've seen. Probably more depth, but it looks sort of more complex, and thus I would guess possibly more expensive. Than sort of like most of the ones I've seen so far have usually been sort of 150 to 200 euros for a kit. I'm guessing this is going to be a bit more expensive.
Yes, this is going to be more expensive. We're sort of like now estimating around 450 euros per kit.
Yeah.
This is, of course, to like we're aiming at the educational sector. We will, when we go to the consumer market, we will lower the price. But in the beginning, we will target like people that usually like they're already invested in 3D printers.
But it grows with you a bit as well. I mean, this is the thing. Like I tested one of the Sam Labs ones. I gave it to a friend's children, and he said, like they weren't really. After they kind of played with it, they weren't really sure what
they
came
could
next.
do. Yeah.
So, and is this still a prototype or is this finished?
This is a finished product. So we're using the Lego bricks for now as a.
But everything is pretty well made.
Yes. So those are like they were made with steel molds, injection molding, everything like in the proper way. The only thing that we are sort of like that we didn't implement in the beginning was. The buttons here. We didn't have the funding like to do the molds and the switch, but otherwise everything.
Can I feel how heavy it is?
Yeah, sure.
Oh, it's reasonably heavy. Yeah. Ooh, hello.
So you can detach it. You can just get a feel of the system. You need to pull it apart because it's locked against like a.
Okay. Feels like you're killing it. So how do you connect to it? Is it Wi-Fi or all Bluetooth? Or
So we built our own protocol because let me just show you how it works. So you plug in this dongle here.
Okay. Wow.
So the way that this works is that you plug this guy in. And as you can see, okay. So let's start with something simple, right? So I'll delete this. We say let's tap into this guy. I'll take some of them out. This guy here, right? So if this one is pink and this one is blue, then they're not paired. They're not connected. So what you need to do is you need to find the pink color either in this one or in this one, and then you just like pair them. When they're the same color, then they're in a connection, as you can see in the app. You can see that it's John 5KA, and there's the label here that indicates that it's this one. So if we put it into a random position, and now we say, okay, we want to make something. So we go into actions, and then we take the block that represents the robot, and we say move to the 0, position on module 5KA. So we do this, we press play, and then it works. Yeah, there was a problem with the USB port, but then it works, right? So, and then we can do like it's always like this when we show you things like that. So we can delete this. And I'll do something.
You have the.
It's built for it.
You have the hardest job for demoing.
Let's see. We turn another one on. So this is 8K. So what I'm gonna do is I'm gonna read the values of the motors of this one, and this one will control this motor, this robot here. Okay. So you can move this one around, and then this one will mimic it. So what we're gonna do is we're gonna put a loop here. We're gonna snap it into this one, and then we're gonna take the angle of robot. What is it? 8KA? No, 5KA. And we're gonna put it into 8KA. And then let's see. We copy paste, and we do the same thing for the Y. And then that's it. So that means that this one is the master and this one will mimic. So we move this one this, and then we press run. So you can try and move this one around. So in this way you can create interactive environments, right? So imagine if this is a sensor on a door and that triggers something. then you can build something that is very interesting and much different than other systems. And it only took one line of code.
Yeah.
Right. So it's something very, very simple.
Yeah. Cool.
And of course, you can go deeper and you can build like a more complex system, like the walking robot and so on. So the idea is that you can
certainly go to a lot bigger depths, can't you? Yeah.
Yeah, I mean, we have neuroscientists like modeling the human brain and using our system. Right? So it's like
that's really just slightly freaky.
And then you can design your own modules, snap them in, so you can experiment a lot.
Will all this be exposed on the final?
I think that for the consumer version, we will use other motors.
No, just because I worry about these cables.
Yes, but the reason why we chose this motors at this point is the cable. It's not a big problem because if the cable, you can easily replace it. So that's something that schools can buy. Yeah. We're selling like a service as well, so they don't have to worry about this. But in later versions, we'll remove the cable, so everything will be enclosed, right? So